We completed about data processing instruction, that is nothing but from arithmetic, addition, multiplication, addition, subtraction, and then we went for AND or, exclusive AND or, then we went for multiply and accumulate, and then we also did the branching thing. Now we will go for load store instructions. Load, always remember you are fetching, and store is always putting into the memory. So it's nothing but load store instructions are nothing but the transferring of data between the memory and the processor register. That's it. You have three types: single, multiple, and then you have about swap. So in multiple, you will be talking about stack operations, push, pop, full, empty stuff and all. Single register is very simple. It is used to move single data item from register. What type of data items? It can be word, half word, bytes, signed or unsigned values. See how it is moving. Load into the register. It's for LDR, STR for loading or storing the word. If you give SB, signed byte, if you give STR, SB, it is storing the signed byte. See, H for half word, storing half word, loading signed half word, STR, SH, storing the half word. Very simple, right? Just basic example, just read it out. It's really not necessary for me to explain it to you. If you just read it, pause and read it, you will be able to understand. You have, this is important whenever you talk about single register load store addressing modes. So there are three addressing modes. This is pre-index with write back, pre-index, post-index. So what happens in pre-index? See, basically it's let me give you an example to explain this. Suppose you are a worker or employee, you do all the hard work. Now it's the time for you to get the salary. If you get the salary, then your money, what we say, balance is updated, bank balance. But if you do not get the salary, if you did the hard work but you did not take the salary, so what difference does it make? You just did the hard work but your balance did not update it. It's just like that. In pre-index with write back, until and unless you write back, it won't update. Okay, and you have this exclamatory symbol for that. In pre-index, it does all the work but it doesn't update the base register. Okay, always remember, memory base plus offset updates the base register. Same way here in post index, remember, it won't be everything under this bracket. This bracket will be separated. It will do the hard work but it will take the salary later. Here it will take the salary and then do the hard. It's like that. Just understand it like that. We have some examples over here. See how it returns. So before it will be only R1. Sorry, here write back, pre-index or write back. So it will directly give this. Here it will give only this because it did not write back, right? So this thing, increment or the pre-index has not happened over here. And here LDR, you just have this. This thing will be same as it is over here, but it will show it later. Okay, so you have, see, this thing is not so different. You just have to remember pre-index with write back and post index. What type of indexing offsets on which offsets? Immediate, register and scaled register. Same thing, see, immediate, register and scale register. Same thing, immediate, register, scale register, post index, post index, post index. So it's not any different. If you can see over here, Rn comma, so all three are Rn. Here just hash comes, here hash doesn't come. Plus division, minus division, minus division, minus. There are two things, Rm is here. Here just offset of 12. Here shift with a shift immediate. Okay. Same thing, you just have to add an increment symbol. It will become with write back. Same thing, what you have to do, remove this last bracket and just put to the Rn. That gives your post index. Very simple, right? Nothing to worry. Now we'll move to the multiple register. Multiple registers, there will be more than one register. So let them be n. N are the total number of registers. So that's the only difference over here. We can see here multiple all these things. Rn is the base registers. Particularly, see how it is more efficient, moving blocks of data. Block of data. See, single data is different, blocks of data is different. Saving and restoring, context switching and stack operations. You have to, and you can elaborate this stack operations by writing about push pop and other extra operations. You can just write about push pop for here if you're talking about only multiple, like in detail. If you want to write more, you can just write about completely in detail about stack operations as well. LDM is store multiple, STM is store multiple. You can just read this. I don't have to explain. I'll just explain. So we had pre-index with the increment, just pre-index. Pre-index is write back, just pre-index and post. Here we have these four things: increment after, increment before, decrement after, decrement before. Increment after was first, it will store the data and then increment. Here it will first increment then store, decrement after. It will store then decrement. First it will decrement then stores. So see here first starting it will be just Rn. So once it at the end it will be incremented. Just incrementation. Why star n is happening? It's because for all the resistors, right? It is performing on all the resistors. So you are multiplying it into n number of resistors. Same way, increment before it is increment being incremented before. At the end, both are same. These both are same, and these both are same. Here we will just have Rn. Here only minus. Here plus. See opposite, 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 opposite. That's it. No difference. One example, if you see, you should be able to understand automatically. Remember this about latency. So usually what it is about, since you have multiple resistors, remember one thing in ARM, whenever instructions are in execution phase, until and unless it's executed, the interrupt won't occur. If the hardware is requesting for an interrupt, basically all the instructions are being interrupted, stopped. But if it is in execution stage, it won't be stopped. So suppose there are multiple resistors, 10 resistors are in being in execution stage. So that waiting time is too much, latency is too much. So that's what they're talking about. Load multiplication takes 2 plus n into t. What is n? Number of resistors loaded. T, number of cycles for each memory access. Okay. So if you want to reduce the latency, then you just have to reduce the number of resistors. Multiple resistors, you have to reduce it to less. Storing and multiple resistors. This store multiple. This is FD, full descending, full descending. This you will understand once you understand the stack operations. See, push means store, pop means load. Okay, STM pushing, LDM storing. Okay, pushing and storing. Ascending means higher memory. Descending means going to the lower memory. Full and empty. Full means it points towards the topmost memory location, last one. Empty means it points towards the first memory location. That's it. So you have stack 4 types: full ascending, full descending, empty ascending, and empty descending. This you will be able to understand better when I show you over here. See, so for full ascending, full descending, early ascending, empty ascending, empty descending. What are the pop? Load LDM, load multiple operations. See, load multiple, decrement after, increment after, decrement before, increment before. So basically after and before. These two are after, then these two are before. But first decrement is having DAIA, and then so it's like da, ya, db, ib, just like that. For STM, it's the reverse. First you have to write, see, ib, see, ib, and then db, db, ia, ia, da, da, just like that. If you remember, it's more than enough. Example, just see it, you should be able to understand. Then we'll move on to the swap instruction. Swap is basically what I'll explain you here. So you have RD destination, RM source register, RN base register. See what happens. The memory function, whatever the old memory is there, that will be sent to a temporary, a memory. Now the source memory is then sent to the base memory, and then this temporary memory is then stored towards the destination registers. Okay, that's what it is here. See how you swap a word. So swapping can be done for word or for byte. Swap B, right? So for word, first you to read the word from the memory at address Rn, then into the R2. Reading from Rn to R temporary. So temporary is equals to Rn, and then it writes the concepts of Rm into, and so Rn is equals to Rm. Then it stores a temporary value into destination registers. That's it. See, it stores to the destination register. For byte, what it does, same, reading the byte from Rn from memory at Rn into temporary, then writing the byte Rm into Rn, storing the original byte into Rd. Original byte is what? Rn, but that value was given to temporary, so that is stored in the destination registers. This is the example, like how before it was and after it was. This you should be able to understand by yourself. I don't want to waste my time in that because I have already wasted a lot of time. Now we have to move to the swap interrupt instruction that we will see in the next video.